Hey guys, I didn't see you there. Well, hey, let's do a quick lesson on perpendiculars and distance. If I drew a line here, let me make it actually a good line. And I have a point here. I think you can see that if I want to measure the distance between that point and that line, it wouldn't be very good to measure at an angle. What the very first key concept it gives you there is that the distance between a point and a line is going to be the perpendicular distance to that line. Okay, I think you can see that. And you know what? I realized that there's something that I skipped. I skipped it way back in chapter 1. And I guess it would be handy for you to know how to do this now. So let me teach you how to draw a line perpendicular to this line that crosses through that point. So get a line, get a point. Actually, let's do the first way is a little bit easier. Let's say I have a point that's on the line. We'll call that point A. And I want to construct a perpendicular line here that goes through point A. So what you do is you take your compass and just measure out in both directions from point A. Put that on point A, measure out, put a little mark there. Go on point A, measure out, put a little mark there. And then just go up. It really doesn't matter how far you go up as long as they're able to cross. Put your compass on there. Make a little arc. Put your compass on that side. Make a little arc. And the point where those two cross, if you draw a line through there, is going to give you a perpendicular line that goes through point A. Okay? If there was a point that wasn't on the line, like the situation that I just drew, so we've got a line, and we got a point up here. I'm dropping everything. And we want to figure out the distance between those. It would be handy to construct a perpendicular line. So here's what you're going to do. Take your compass, put it on point A, make it long enough that it goes well over the line, and cross the line there and show where you cross the line there. So basically you're going to cross it at 2 points. Then just move this to one of those 2 points and make an arc kind of like what you did. Make another arc so they cross. At that point where they cross, if we go through that point, it's going to be a perpendicular line. And I'll do that really quick. Try not to drop anything this time. So approximately like that. And now you have a perpendicular transversal that goes through point A, which was right there. All right, there's 2 ways to do constructions. And again, the distance between that point and that line is the perpendicular distance. If we have 2 parallel lines, actually, you know what? I don't have to make this perfect. 2 parallel lines. The distance between those parallel lines is going to be the perpendicular distance, which I think makes sense. It would be crazy to measure it like that and say that's the distance. Okay. I honestly think that's about all there is to this chapter. They're going to ask you some different questions. And in real life, like let's say here's one I could think of. Sometimes when you make a house, you make what's called a truss for the upper roof part. The truss involves a roof joist and then the rafters. And the rafters are going to a central place. They go back up here and over here. You've probably maybe seen that as people are building houses. So if I'm a carpenter and I want to figure out, I want to have a support beam going up here, I want to figure out how far from there to there. Well, I'm going to measure the perpendicular distance there to get that. You want things to be pretty much perpendicular, straight up and down, or dead level with a house. You don't want them to usually go at these crazy angles. It's just not as strong. So anyway, I would measure from there, and I'd measure perpendicular to there. There's a real life example, okay? There's lots of them. You're going to have fun doing some homework in the book tomorrow. Okay, bye.